Welcome to Part 3 of the Design and Technology Lab's CNC Rotor Guide. This video will demonstrate the basic functions of Rhinocam and show you how to program simple CAD files into toolpath instructions for a CNC rotor to follow. Rhinocam is a CAM plugin that runs completely inside of Rhinoceros. The Design and Technology Lab uses this software to program and run CNC operations directly on the Multicam CNC. Assuming that your CAD file meets all the requirements from the previous video, it should be set to inches, organized into layers, and clean of any miscellaneous items outside of your model, stock, and control geometries. The following steps should be completed in lab on the CNC rotor's dedicated computer. With your CAD file open in Rhinoceros, open Rhinocam to Mill. Here, the operating lab technician will work with you to select machining toolbits for your design, generate toolpaths, simulate your toolpaths, and post your G-code instructions to the CNC rotor. Start off by selecting your modeled stock. Then, click on the Stock dropdown in the Program folder of Rhinocam and choose Stock from Selection. This tells the CAM program what and where your stock is. You can now turn off the stock layer in your Rhino model. In its place, you should see a new stock geometry created by Rhinocam. You can toggle its visibility in the bottom left-hand corner of the Rhinocam browser. For 2D milling operations, select the geometry in a single sublayer under your control geometries. Then, under Machining Operations, select the corresponding 2-axis operation. In Rhinocam, 2-axis refers to the same thing as 2D. Under the Control Geometry dialog, you should see your Select Machining regions, which corresponds to the curves in your Rhino modeling space. You can arrange the cut order of these regions by selecting a drive region and choosing Move Up or Move Down. With the assistance of the Operating Lab Technician, choose the appropriate toolbits for your project under the Tools dialog. This depends on the type of operation and your desired results. While there are various toolbit options for CNC routing, we will be discussing a selection of the most commonly used. For most 2D milling operations, such as profiling and pocketing, a flat mill toolbit is recommended. For more detailed 2D milling operations, such as engraving, a V-mill toolbit is recommended. Under cut parameters, you can make specific adjustments to refine toolpaths. Defining whether you want an inside cut or an outside cut is important to accommodate for the diameter of the toolbit. When programming for profiling, which is considered a positive cut, you typically want to set your cutting side to outside. This tells the CNC to only remove material outside of the defined geometry. When programming for pocketing, which is considered a negative cut, you typically want to set your start point to inside. This tells the CNC to remove material within the geometry. The step-over distance is the distance the toolbit shifts after each pass. This is measured in percentage of the tool diameter. Typically, 25% tool diameter is used for 2D milling operations. The lower the percentage, the cleaner your milling results will be. However, it will also increase the milling time. The cut direction defines how the toolbit bites into the material. A CNC rotor can either use a conventional cut or a climb cut. However, you should generally choose a mixed cut, which includes both cutting directions and allows the software to choose what to use. Under cut levels, input your total cut depth as previously specified on your Rhino layer. For 3D milling operations, select your surface geometry from the Rhino modeling space. Begin by choosing horizontal roughing as your first 3-axis pass under machining operations. Instead of appearing in your part regions list, your geometry selection will appear under part surfaces. In 3D milling, a flat mill toolbit is typically used for the roughing pass. Under cut levels, set the step-down control to 50% for hard materials such as wood and composites and 100% for soft materials such as foams. Under cut parameters, you can set the step-over distance between 25% and 100% depending on how precisely and how quickly you'd like your roughing pass to be completed. Next, follow the same steps to set up parallel finishing. In this case, where a multi-tiered surface is being created, a ball mill bit is most commonly used and recommended to achieve smooth transitional surfaces. However, this can vary depending on your desired finish. If you'd like to use a custom tool bit outside of the Design and Technology Lab's tool library, please make sure you consult with a lab technician to properly load and install your tool. Keep in mind that you cannot achieve cuts that are deeper than your tool bit's flute length. For finishing, it is recommended that the step-over control is set to 25% tool diameter or lower for clean results. When you're satisfied with your settings, click Generate to see your toolpaths. The light blue lines represent straight toolpaths, the dark blue lines represent curved toolpaths, and the red and yellow lines represent the tool's movement from one cut to another. In your Rhinocam machining browser, make sure your roughing toolpath comes before your finishing toolpath. If not, you can easily rearrange it by selecting and dragging. With hard materials, skipping horizontal roughing before parallel finishing may result in faulty cuts, broken tool bits, and the stock being flung from the CNC bed. For prototyping purposes, soft foams can normally be CNC'd directly with a finishing pass. However, you should always consult a lab technician to be sure. With your toolpaths generated, you can now run simulations of your operations through Rhinocam. While the simulation is not 100% accurate, it will give you a good idea of how the CNC rotor will perform your operations and where any errors may occur. If your selected tool bit is shorter than the depth of your cut, you will receive a simulation error that warns of shank/holder collision. In other words, a longer tool bit is required for the job. To see the stock in simulation more clearly, you can toggle the part visibility and the toolpath visibility. You can stop or pause the simulation at any time. The simulation speed can be adjusted using the simulation speed meter. To quickly run through the simulation, set the simulation speed to maximum and select Simulate by Moves. To skip the simulation, click Pause and choose To End. Other simulation options, such as Simulation Model and Accuracy, can be adjusted in the Preferences dialog. If you're unhappy with the simulation results or if error occurs, you can simply readjust your cut settings by double-clicking on the Operations folder. You can also check your machining operation information to see the estimated machine time and other information such as number of tools and operation status. Once your toolpaths are created and your simulation is free of errors, your G-code instructions can be directly sent to the CNC rotor via post. Make sure your post processor is set to Multicam Inch Rev 1 and your file extension is set to .nc. With your Rhinocam setup complete and your G-code instructions posted to the CNC rotor, you are ready to move on to the final step, CNC operation.